Hi, I'm Dr. Augsburger and I'm a physical chemist. What that means is I start with the principles of physics like quantum mechanics and thermodynamics and use mathematics to then generate the principles that govern chemistry. And those principles tell us how the structure and the function of a molecule go together, and those things are really important. For example, if we wanted to create a new catalyst that might speed up or increase the rate of production of some new high-tech material, or even to create a new pharmaceutical that might treat like COVID or cancer or something like that. Understanding those principles are key to being able to do that successfully. My students use computational modeling tools to do these kinds of studies. Most of the work is done with a program called Gaussian that is the most widely used of these softwares among chemists worldwide. A couple of projects that I'll just mention that we've worked on have to do with reactions that either did or didn't happen the way they were expected to. And the first example involved a reaction, and this molecule I'm showing you this movie over here was actually involved in a reaction that wouldn't have been expected to have worked. And part of that came from is this model, this little movie is showing, even in the solid state, it moves inside the crystal. So we wanted to model that. So then we put together this big model where a whole bunch of other molecules stacked around that to mimic it being in a crystal. And the project was successful enough that we were able to go to a conference put on by the American Chemical Society in Omaha, Nebraska. So there were researchers from the Rockies to the Great Lakes that were there, and they got to present their results and meet the actual researchers who had done the original discovery in the first place. Another project that I worked on started with when a former student of mine in grad school was trying to find a new pharmaceutical compound, and he found a compound that was not expected to be stable, but was. So a different student and I worked together on that for a while, and eventually some of our results ended up being successful enough that we published them in a paper in the Journal of Physical Organic Chemistry, and they were actually gracious enough to put our illustration on the cover of that issue. Students who do research gain advanced problem-solving skills and develop laboratory or modeling expertise that will give them a leg up on any career they want to go on into in chemistry.